slides.
Yeah, thanks, Ashkan. So thank you all for sticking around. These are the lightning round talks, and as Yvonne mentioned earlier, these are some of the best opportunities for you to be engaged in what the next generation is actually doing in the labs, and so we started this lightning round talks I think maybe 3, 4, or 5 years ago now. I don't even remember, as a way of rapidly disseminating a large amount of information from the next generation, and so with that, these lightning round talks are 1.5 minutes, no more. There are no slides and no questions, but this is an opportunity for them to come up and engage you and interest you in what they are working on. And so I do encourage all of you to find these students at some point. Go ahead and come on up over here to the side of the podium and go ahead and line up. And so please again, hold your questions, but do seek them out during the poster sessions and at breaks to find out more about what they're doing. I do have a large candy cane hook so that if you do go over 1.5 minutes, I will yank you off the stage. So Ashcon turned them on, I think. Yeah, I think we're good. So with that, we'll get started with Chris Wilnett.
Oh, there you go. Good afternoon. My name is Chris Womack. Oh, sorry. Yeah. Afternoon. My name is Chris Womack. I'm an undergraduate student at the University of Colorado in Boulder, studying electrical and mechanical engineering. I work with the labs team at the Center for Astrophysics and Space Astronomy with under Dr. Jack Burns. And I just wanted to tell you a little bit today about some of the research we've been doing in conjunction with Lockheed Martin. They essentially wanted to study how teleoperations are affected by network quality and what are some of the bandwidth requirements for these types of operations. So over the last year, we developed the telerobotic simulation system that allows a person to essentially operate a robot remotely, and we can change things to the network quality, such as frame rate, latency, and resolution, and study the bandwidth and then how this also affects the person. We're located in the back for the poster sessions. I'm poster number 9, and if y'all have any questions or would like to discuss this further, y'all just swing on by. Thank you for your time.
Good afternoon. My name is Stephen Jarrett. I'm a graduate student at Stony Brook University with the RISE team, and I'm interested in impact events, and particularly I care about how we know when these impact events happened. This is really important for the moon, for example, where a lot of the history is tied in these impact events, and they're tied in absolute time to samples, many of which are shocked. So the question I ask is, when we get an age on these shocked samples, what is it reflecting? Is it reflecting the original age that rock formed, or the age when it got slammed into by something else? So to test this, I am using the crater Manicouagan impact crater here on the Earth, where we know the age of the target, and we know the age of the impact, and there are these shocked rocks. So we've done argon analyses on these. It turns out, in a lot of the cases, you get an age that doesn't look like either the target age or the impact age. So this sets up a lot of questions and challenges. So if you're interested in the moon, impact cratering, chronology, come find me. I'll be at poster 17. And again, my name is Stephen Jarrett.
Hi, my name is Sue Ann. This is Jennifer. At the back of the room, we have Afton, Stephen, and Kevin. And we are the Bel Air High School team from Houston, Texas, who through XMAS, an educational outreach program, was able to study asteroids during our high school career. And Jennifer here will help explain exactly what our research entailed.
All right, so our project dealt with hypothesizing the former existence of a differentiated protoplanet between the orbits of Mars and Jupiter. To start off, we read many papers and we noticed that 17 M, A, and B type asteroids near the 5-2 Kirkwood gap exhibited characteristics corresponding to nickel iron core, olivine mantle, and basaltic crust of a differentiated parent body. And since these asteroids are all far enough from Vesta, we think that they might have originated from this different parent body, which we named Zhuque in deference to our school's mascot, the cardinal. Zhuque means vermilion bird of the south in Chinese. And we believe our protoplanet might have been disrupted by collisions during Jupiter's grand tack. So by mineralogical composition and orbital proximity, we believe that 16 out of the 17 asteroids studied actually originate from Zhuque. If you would like to know more about our calculations, please come see us. We are poster 17.
This 74.
Sorry. Okay,
74.
74.
We're poster 74.
I'm not good with numbers. Right. Thank you. Our study sheds light on possible scenarios of solar system formation and asteroid belt evolution. Future investigations might involve computer simulations of Zhuque's disruption and the time evolution of the remnants. We are high schoolers. We do not know how to do this. If you do, please come and tell us. Thank you.
Again?
Okay.
That works.
Okay.
Hello everyone, my name is Gen. I am a student at Stony Brook University in New York. On Thursday, I'll be giving a talk about testing the incorporation of infrared imaging for future human missions. In this, we experiment this instrument, which is a candidate prototype instrument, which mimics real potential instruments that can go on and be used for future human missions to planetary surfaces. The RISE field team, Remote In Situ and Synchrotron Studies for Science and Exploration, conducted a field operation last month in Hawaii, in Kilauea Volcano, and tested the use of this instrument. And this instrument detected spectral signatures from different soils and rocks and was capable of providing compositional information. This was, or it showed a very promising and very exciting potential for human exploration and human missions to planetary surfaces. At the same time, though, our work brought forth new questions and the need for more investigation. I'll be talking about this more during my presentation. Again, it will be on Thursday at 1:30 in this room. Thank you.
Hello, my name is Dan Moriarty, and I'm a graduate student at Brown University working with Carly Peters. I've been looking at Mafic Mound, which is a unique topographic and compositional feature at the very center of the deepest part of the South Pole Lake and Basin. So in my talk tomorrow morning, I'm going to use M-cubed, Grail, LROC, and LOLA data to argue that Mafic Mound is actually a magmatic construct that's directly related to the formation and evolution of SPA. So I'm really excited to talk to anyone interested in these processes. So if my talk makes you happy or angry or any kind of emotion, feel free to look me up. Thank you.
Hello, my name is Erica Jowen. I'm also a PhD student at Brown University. So I have two quite different research projects. One of them has to do with glaciation on Mars, so I won't be talking about that here. But my survey-related research has to do with detecting volcanic glass in lunar dark mantle deposits. So I'll be explaining what all of that means in my talk, which is at 4:55, or slightly after, depending on how long the previous talk goes, around 4:55 in the other room. But I'd like to talk right now about why the project is important. So from a survey exploration perspective, dark mantle deposits represent a very promising area of potential human habitation for long periods of time. And again, in my talk, I'll explain why that is. So that's one aspect of why this project is important. But I also think this project is really important because of the collaborators and my co-authors. First of all, 4 out of the 6 co-authors are women on this project, and that is actually still quite unusual in planetary science these days. That's, yeah, thumbs up. That's something that I find really important. But the other part of the collaborations is that it's quite an international project. I actually started the research in the Netherlands at the European Space Agency, and I have collaborators that are from the Netherlands and from Canada, as well as research locations around the US. And I find that this is actually crucial to the future of exploration and scientific research in planetary science. As Carly and as Clive mentioned this morning, international collaboration is not the only way, but it's going to be the best way that we can actually make manned exploration happen. And other than an exploration perspective, research done among international collaborators is going to be more robust in and of itself. And so I believe that my research really represents what I like to think of as the future of planetary science, research and exploration, both from an increased diversity, from a gendered, racial, national perspective. And please, again, I'm Erica Jowen. Come see my talk, 4:55 or thereabouts. Thank you.
Can we get one more round of applause for all of our lightning round talks? We do have 2 more sessions of lightning round talks, one tomorrow morning and one tomorrow afternoon. So if you are looking for future graduate students or postdocs, please join us and hopefully you'll find a diamond amongst other diamonds. So that said, we're going to take a small break and transition into the parallel sessions. In this room will be future missions of science and exploration chaired by Barbara Cohen and Chris Zachney.